So, hello everyone, good morning. Any questions for this morning? So, what we're going to do today is look at some library to do graphics. And then at the end of class, maybe the last 10 minutes, I'm going to have you work in groups. It is for this time, we won't be doing it in class all of the time, but to get started on the written exercises so that you can get to know your own group. So let me here share a screen, and we're going to talk about graphics a little bit first. Let me make some room here. So what we have seen so far is how to write a class, and went over the person user example. And there is a video available on Canvas. If we go to our class under week 2 here. So this video is explaining how to do graphics. I'm going to go over graphics today, but if you haven't seen that video, look at it. It's going to explain it in more details. And then we're going to start looking at an example that is going to be explained. This is a video from previous quarter, but this video here is going to explain how to do graphics to create a smiling face. And this is something that's going to help you for your first homework assignment. Okay, so let's start looking at graphics. So if you want to do graphics in Eclipse or in any other platform, well, you need a graphics library. If you have Java, actually, Java comes with a graphics library, but it is a library that is at the professional level. So it has lots and lots of features. We don't need to use all of that for our class. So we're going to use a simpler library that has been developed by the UW. And it's available on our class website. In different places, but one place where you can have it is here. So you will need to download this file if you haven't done it yet. So once you have downloaded that file, so you download it, for instance, by saving a save link as here. I already have it, so I'm not going to do it. And you want to bring it inside of your project. So how would you do this? Well, I have it already here, but I'm going to remove it and then add it again. So one way of doing it is once you have created your project, you can go to the properties here, and you will select Java build path. And you see here you have a tab that says library. So if it's not open, you open it. And under class path, don't select module path, under class path here. So you would add your library. So I'm going to remove it, and then I'm going to add it again. So let me remove it here. So I would have nothing here. So I would select class path. Then you would select add external jars. What is a jar? It's an acronym for Java Archive. And it is so a set of compiled classes. So you have bytecode, and it is compressed with the zip format. So it's like a zip file. So you would say add external jars, and then you need to navigate to where you have downloaded your library. So you see you would download this somewhere. Remember where it is. When you're in Eclipse, then here, when you click on add external jars, this is where you go. So if I do this, for me, I have it in there somewhere. It is this one here, uwcsc.jar. So I would do that. And now that I have it here, I just say apply and close on the libraries here. So if you open the library here, so you get, you see plenty, these are packages. And the package that contains graphics is uwcsc.graphics here. So if you open that, you see that you have plenty of classes. So remember that, so when you write code, the code is stored in a .java file, like here person.java, but then that code is going to be compiled into bytecode, and the extension for that is .class. That's why here you have plenty of .class files here. So it's bytecode, all of this. You can see your own bytecode for what is done in a project. You see if I go to the properties here, and I go to the project, would that be, let me find that here. So if I go to resource, you see it gives me the location of the project. So if I click on this, I'm gonna see the folder. And if I open that, and if I go to the bin folder, we never look at it, but this is where the .class files are gonna be. See, so the two classes, person.java and person_user.java, they have been compiled, and this is a bytecode. So you cannot read this. It's well, you could, but it would be just a bytecode. It is a binary file. So this is what we get for our graphics library here. So how do you know how to use that? Well, it's not by looking at this. I mean, you could double click on this, and actually you're going to get a little bit of a source code, but it is best to go to the documentation. So the documentation, you can download it here if you want to, but it's also available here online. So if I click on this, I'm going to get it. And so here is the documentation of the graphics library. So you see that it doesn't have lots of classes, just a few, but it's good enough for us to get used to using a set of classes in a library. So you can recognize or get an idea of what it can do. So for instance, here you have a class, a G window, that allows you to create a graphics window. That's what the big G is for. And you can also create a few shapes. So you can create a line, you can create an oval, you can create a rectangle, you can create a triangle. So how does it work? Well, of course, we have to look at the documentation. So the way it works, basically, we're going to create a graphics window, and then we're going to add elements at different locations to the graphics window. So how do you create a graphics window? Well, let's look at it. If I click on G window here, I'm going to get the documentation page. So you see that here we have links to constructors and methods. So first of all, they give you a general description of what a graphics window is. And so you can add and remove elements from the graphics window. And so how do you create a graphics window? Well, we have constructors available. So you see you have different types of constructors available. The last one is maybe the most complete one. So what do you do with this one? Well, it's not much. You see, you can give the size of the window. It's going to be in pixels. And you can also give a name to the window. So what does it mean to give a name here? Well, it means that when the window appears in the task, in the bar, in the window bar that you have at the top, you would get the name of, well, the name, whatever you write here. And then there are some methods that you can use for a graphics window. So add, for instance, this is what we use to add something to a graphics window. If you want to remove it, you have this as well. And how do you create so the graphics window? Let's do it together here. Let's see how that goes. So let's create a class here. So it's going to be a graphics example. So let's have a main method in there. So remember that main is always the starting point of the program. So I can have main, so I can just type main like this in Eclipse, and then if I type control space, automatically it's going to complete main to give me the full signature. We have not explained the signature. The signature, we call it is the first line of the method. So if I say give me a main method, and then it's going to give me all of this here if I click on that. So this is always how the main method should look like if you want it to be understood as the first method that's going to be executed in a program when you click the run button. So let me select this one. And so here, what I can do is I can create a graphics window. So how would I do it? Well, we've seen it here. I need to call the constructor. How do I call a constructor? What's the keyword for that? So how to call the G window constructor here? What should I write?
Don't you need to grab the class and stuff? Like it would be like trying to remember the words for it.
So are you thinking of import?
I think it might have been import. I'm not quite sure what it was.
There will be that, but let's say we have it. So indeed, we're going to have to deal with this. But what is the keyword that we use in Java when you want to call a constructor? When we created a person, we call the constructor, and it's always the same syntax to call new indeed, new. So you want to say new, and then you give the name of the constructor. So the constructor has always the same name as the class. So it would be GWindow with a capital G. And then what you put between parentheses, well, it depends on which one you want to use. And it's given here in the documentation. So let's say we want to use this one. So this is telling us that to call that version of the constructor, I need to give first a string. So it's going to be the title of the window. And then I can give 2 integers, and it's going to be the size in pixels for the width and the height of the window. So I can do that. So here, so between parentheses, here I could say, well, that's going to be what appears here, graphics window. And then I can say, oh, it's going to be 800 by, let's say, 500. So if I do this, I'm going to get a graphics window that's going to be displayed, except I have a problem. As you can see, GWindow is underlined in red. So why is that? Well, it has to do with what was said a few minutes ago. We have to say, I want to get the graphics window class indeed. So as you said, it has to be imported. But let's understand what it means. Because when we say import the graphics window, it looks like, well, we have to go somewhere and somehow copy it in our project. But it is already there. So indeed, you can have it automatically imported, but let me do it step by step. So we already have it in our project. It's here. The class is here. So the project should know about it. So why is it that it doesn't know about it? It's not because it's not there. It's because this name here is not the full name of the class. If you look at the documentation here, you see that actually the full name of the class is that. So it is the class GWindow, but it is in a set of folders. We call these packages in Java. So we need to say, use the GWindow class inside of the graphics folder, or I could say graphics package, which is itself inside of the UW CSC package. So really, if I want this to work, I would have to write here UW CSC.graphics.gwindow. And then you see that all is good. So if I do this and I run my program, it's going to be fine. And I get, you see the title here, graphics window. So it's 800 by 500. I can close the window here. So this is what we have here. But of course, typing this is, well, not very convenient. So we can use a shortcut, which is just using the name of the class without having to say, we want the class which is in the folder UW-CSC that contains the folder graphics. So this is where the import statement comes in. So when you say import, we're just saying, well, when we use a GWindow in our program, we mean uw-csc.graphics.gwindow, nothing else. So maybe import is not the correct name. It would be more maybe something like a shortcut or whatever, but that's how it is here. So you would write here at the top, import uw-csc.graphics.gwindow. And so if you do this now, you can take this out. Now, GWindow is going to be understood as meaning uw-csc.graphics.gwindow. So again, import is not really a strong statement. It doesn't copy any file in the project. It is just saying that in the code, GWindow means uw-csc.graphics.gwindow. And now I can run it, and I get the same thing as before. So now, once we have that, of course, we get well, a graphics window. It's not too bad, but maybe it would be nice to add elements to the graphics window. So how does this work? Well, what you can do is, for instance, create a rectangle, and then you can add the rectangle to your graphics window using the add method that you have here. Of course, we need to look at how does a rectangle work. How is it created? So if you go to the rectangle class here, this is how it goes. So when you create a rectangle, you're going to specify a location XY. You're going to specify the size of the rectangle. You're going to specify the color of the rectangle. And then you're going to specify a Boolean. And this is to say, do you want a rectangle with just a border, or do you want a rectangle that is fully colored? So if there is a coordinate x and y here, so a point with coordinates x and y, we need to understand the coordinate system of the window. So this is how it goes. So when we create the graphics window, so say we have created a graphics window. So you have the title bar at the top here. And you can have an origin. The origin is here. So this is the origin of the coordinate system. Oh yeah, Michael, here you were. Yes, thank you for the answer here. AWT is, so there are some features of the Java libraries that we're gonna use, for instance, for color. And indeed, they come from a package called AWT, which is itself in the Java package. So here we have the origin, 0, 0. And what are the X and Y axes? Well, the X-axis is as usual, like this. The Y-axis is, well, slightly unconventional. In math, we are used to our Y-axis going up. In computer science, in graphics, very often it goes down. Why is that? Well, it's kind of like you see the same way as when we write on a piece of paper, we start at the top and then we go down well, most of the time. So this is our Y-axis, and it's going to be all in pixels. So if you have a window which is 800 for the width and 500 for the height, the X coordinate is going to be from 0, because you start at 0, the last one is not going to be 500, but it's going to be 499. On the Y is going to be from 0, I'm sorry, 799, because it was 800 for the width. And here for the Y, it's going to be 499. So when you say, let's create a rectangle, so you give some coordinate X and Y. So you're going to have some coordinate X here, let's say Y. And you get a point in the window. What does that point represent for the rectangle? It's going to be always, that's the way it's defined in the graphics library of the UW. It's very often the case, actually, for mini graphics library. It's going to be the top left corner of the rectangle. So the rectangle is going to be drawn like that. So XY, it is the top left corner. And then when you specify the width, so of course, this is going to be the width. This is going to be the height. And then, so this was what is given here, you see. So XY here. And if you don't remember, you can always click on this, and it's going to tell you what it is. And so you see that X and Y, it is the top left corner. So width and height. So the fifth parameter here is going to be the color. So there are some predefined colors available in Java, and they are available. So there is a color class, which is itself, so in a set of packages. So it is, so the package Java has a package AWT that contains all kinds of graphics classes. So if we open the documentation, and you look for color in there, so here we have it. So you're going to see that there are some predefined colors available. Here they are. You can also create your own colors using, so there are all kinds of constructors, but for instance, you can use this one where you specify the amount of red, green, and blue. And this would be numbers in the range of 0 to 255. But you can also use predefined colors. So here they are. You might wonder when you look at this, why is it that for every color we have two versions, one uppercase and one lowercase? Is there a difference? So the answer is no. But it is historical, and it is, well, a style mistake that was done at the beginning when the libraries were created. So the style in Java is for anything that is a constant. And so these colors never change. So they're constants. So when you define a constant in Java, the style is to have the name of the constant all uppercase. Except they didn't do this for the first version that they released. So when they released the color class initially, they had constants, but they were all lowercase. And then they realized, oh, but it would be nice to have that style all uppercase. So then they added this later. But once you release something, you cannot change it. So that's why now they have to carry the two spelling of them in the two styles for the colors. But they're the same. And how do you say that you want to grab a constant color from the color class? So this is how you do it. So let's say you want the color red that's available in the color class. So you would say name of the class, and then dot the name of the constant. So and it's a good, you could write red lowercase, of course, but it's a good idea to use a style that says a constant, so all capitalized. Why is it that here we use the name of the class? Let me say it briefly, and we're going to explain that keyword a bit more, but it's because these are using the keyword static. So static, it is a keyword that we're going to see a few times in our programs. It means that it is a feature. Static can be used for a method, or it can be used for a field. And it means that it's not something that is associated with an object. It belongs to the class directly, and it doesn't exist within an object. You see, when we talk about the person example here that we had, age here, for this variable to exist, we need to create a person object because it can only live inside of an object in memory. When you have something static, actually, it's not something that is associated with an object. As soon as the class is loaded by the JVM, these static features are available. And you access them by using, you see, when we wanted to access, well, not really age and name because they were private, but for instance, speak in code, we needed to have an object created, p here, and then we had to say p.speak. But now if you have a static feature, you never create an object because it's not something that lives inside of an object. You just use the name of the class. That's why when you want to access red, you say color.red here. And then the last item that we have here in the constructor for our rectangle is a Boolean. So if it is true, you're going to get a solid color for the rectangle. If it is false, it is just a border of the rectangle that's going to be a color. On the inside is going to be, well, it won't have any color, so it's going to be whatever the color of the window is. So let's see how that goes. So if we were to look at our graphics example here, so we could create a rectangle. So let's do it. New rectangle. So let's say I put it at location, I don't know, 50 for X, 100 for Y. Let's say it has a size, a width of 85 on a height of 41. I'm making these numbers as I move along. Then I would like to have the color red. So I would say that. And then let's say I would like to have it filled. So here is my rectangle. So I have several problems here. Well, this one, we start to know about it. I need to import the rectangle class. And again, it means just when you see, I'm just stating, so the compiler, when you see rectangle, I mean u.csc.graphics.rectangle. So Eclipse can do it for you. So you have to be careful here because you see we have access to different libraries. There is also a rectangle class inside of java.awt. You don't want this one. You want the one from the UW. So I'm going to click on this, and then the import statement is added up here. Color is the same thing. Color is a class that is inside of the package java.awt, so I need to import it as well. So here I have it. So now what is this going to do? It's not going to create a rectangle inside of the graphics window. I need to add the rectangle to the graphics window because as we've seen here, when we went to graphics window, we have a method add here. But if I want to use add now, I need to have a variable that refers to the graphics window that's going to be created in memory. It's what we did, for instance, whenever for the person example, if I wanted to make the person speak, well, I needed to have a variable p that points to the person object, and then I can use it to have it do something. So here it is the same thing. I need to create a variable that can refer to the graphics window object that's created here. So as usual, that variable must have the same type as the type of the object that is created. So I need to have a gwindow here, a gwindow variable w. So you have to say, to tell the compiler, give me a piece of memory that I'm going to call w. In that piece of memory, I'm going to store, and we know now how it works. We saw it briefly with a string, but we're going to have an address in that w. That's going to tell us where the object created here is going to be. And then given that, I can add my rectangle to the graphics window. So I could say this, w.add, and then directly something like this here, new rectangle, like this, but maybe that's not very clear. A better way could be to create a rectangle here. That would be that. And then I can just say w.addr. So if I do this now, I'm going to get a a rectangle in the graphics window. Here it is. And so that rectangle is, the origin you see is here. So that rectangle is 50 pixels along the X direction here, and 100 pixels down, because remember the Y-axis is directed down, so 100 pixels down here. So this is our top left corner, that's a 50, 100, and then the width is 85 pixels, and the height is 41. And we have the red color here. Now, if I had this false instead, let me close what I have here. So you can click this button to end your program here. So if I run it again now here, you see I just get the border of the rectangle. So that's how we can use graphics elements. So there are all kinds of graphics, well, all kinds, a few graphics classes available. So the video on the example on the class website is giving you what's available. We can bring it back here to see it briefly. So if I go there, see, so you have here our first graphics app here. So let me bring this back. Let me put it in our source folder. And now, if I refresh this, I'm going to be able to see it. This. So if I open it here, so you see all of the import statements here. So now you see we are using a rectangle, but we're going to use a triangle as well here, a polygon, an oval. So if I run this now, this is what I get. So you see you get, so this is the oval, this is our triangle, this is a rectangle, and this is a polygon. So how do you do it? You well, use the different libraries, the different classes listed in the libraries, and how do you use them? Well, you look at the documentation, but it's basically always the same idea, using a set of coordinates. So for instance, here you recognize a rectangle here. For the oval, it's going to be very much like a rectangle. This is how it works for an oval. You give it the same information as for a rectangle, but it's not going to draw a rectangle. It's going to draw an oval, which is tangent to the four sides of the rectangle. So when you draw an oval, you give it exactly the same parameters, but this is what you're going to get. You're going to get something like this for an oval. For a triangle, you give it the three vertices of the triangle as coordinates. And for a polygon, well, you start with something empty, and then you can add as many points as you want. So this is how you can use the different graphics classes in the UW library. So questions at this point? So what we're going to do next now is see how we can use the graphics library to draw a picture that is more interesting than what we have seen here. And what we'd like to do is draw a smiling face. And the reason why we are doing this is because your first homework assignment here, I go there, it's asking you to draw, you see a fish, a sailboat, a star, and also a fourth element of your choice. But so how would you draw, for instance, a sailboat? Well, we here, I'm not going to go into the details right now, but the sailboat class is going to be created. On the inside of that class, you would explain how to display the sailboat. So we're going to do it for starting to do it with a smiling face, and then it's going to be explained in more details in a video that's already posted on our class website. But let's work together on how we would do it. So let me delete this. So this is what we'd like to do. We'd like to, in our window, we'd like to be able to create a smiling face, but to be able to draw as many as we want, and with different sizes. So something like this, possibly here, and then maybe a big one here. So we'd like to create plenty, well, as many as we want, smiling faces like this. So we're going to create a smiling face class. And that's so it's going to be something like, well, for instance, you have the rectangle class available in the graphics library. Well, there is no smiling face class, of course, available in the UW library. So we're going to create our own, but to draw it, of course, we can use elements from the UW graphics library. So we need to think about, well, how would we define, what elements would we need to create a smiling face? So first thing that we could ask is, what about the location? So how would you define, what would we need? So here I'm trying to think about the state of the object smiling face. And that's going to tell us what kind of instance fields we could have. So how would we say, where is the smiling face? Because we want to be able to draw it at different locations. Go ahead.
Wouldn't it be like on the maybe like negative 50x or something for one of them, and that maybe like upper like a positive y value for the left one, then like positive x and maybe y equals 0 for the right one?
Indeed, so we can have some kind of so we need to have a set of coordinates. So we could say in general it's going to be at some location xy. But this is where the design comes in. You see, for the rectangle, we said we need to have a location, and they said, oh, this is going to be our location xy for the rectangle. So here for the smiling face, we have to decide where we would like that location to be, and then we can draw everything with respect to that location. So what could be a good point on the smiling face that is our reference point for the, well, that is the location for the smiling face. Because you see, a smiling face is not just a point. So when we say it is at xy, we're going to have to say, well, is it the top of the smiling face? Is it the center? Is it the bottom? So what would be a good location for it? A good choice for the location. The center, indeed. The center is a good idea. Well, you could, of course, take any point in the smiling face, but maybe the center is the best one. So this is a question of choice. It is a design. Somebody could say, oh, I want my reference point for the smiling face to be that point. That could be okay. But for us, we're going to take this, the center. So we're going to say the location is going to be the center here. But it doesn't have to be that. So this is telling us that if we were to create a smiling face, let's do it here. So let me create a smiling face class here. So I could have here the instance field, so location of the smiling face, and it's going to be so the center. And we would say we have two instance fields, x and y. So you can declare your instance fields if they have the same type on one line like this. You don't have to say private int x, semicolon, and then below private int y. You can. Okay, so that's one feature of the smiling face. What else do we need for the smiling face? You see here, we would like to draw possibly big smiling faces or small smiling faces. So what could we introduce to as a
size state?
Right, a size, yes, indeed. So precisely, I mean, it's like size. We're going to have, if you want, a default size for the smiling face. That is, if you were not to say anything, this would be the size we would use. And then what we can introduce as an additional field is a scale. So if the scale, for instance, is 2, it means that we take the default size and we take, well, all of the default sizes, because when we say size, it's going to be the size of the head, but then maybe the size of the eyes, the size of the nose, the size of the mouth. So all of these would be multiplied by that number, scale. Now, what do you think should be, so we're going to use a scale. Doesn't have to be in red. So we need to have a variable for that. So some number. What would be the type of that number? So remember, by type, I'm asking, well, should it be an integer? Should it be a floating point number? So the idea would be
a double.
Yeah, exactly. So you don't want it, you see, to have it as an integer, because then the size would be limited. You could have only a size of 1 or a size of 2, I mean a scale of 1, a scale of 2. So well, of course it would give us different possibilities, but for instance, we could not make it smaller than the default size, because if you want to make it smaller, like half the size, you would have to multiply everything by 0.5, but that's not on int. So we're gonna use for the scale a double. And again, on int is not, it's not as if you cannot have an integer scale, but if we use an integer for the scale, our choices are limited, and we cannot make the smiling face smaller than the default size. You could say, well, let's multiply by 0, but if we do it like that, of course, it will disappear. So we can have also the scale of the drawing here. So we would say private double scale. So given that, then we're going to be able to draw our smiling face, because this is the only information basically we need. Why is that? It's because let's say somebody says, draw a smiling face at location XY with a scale. So let's say we get the instructions, draw a smiling face. And I'm making this up on the fly here at X equal 100, Y equal 200, and with a scale of, so with a scale, write scale correctly here, with a scale of, let's say, 1.5. So then it could mean that in the graphics window, we have our X and Y coordinate system. So we would go to 100 for X, 200 for Y. So here we get that point. And then we have the scale. So of course we make choices, but that's going to be choices within the smiling face. Let's say we have a default size for the head. So we say the head size or the head radius, let's say it's 50. Then 50 times 1.5 is going to be 75. So then we would draw a circle of radius 75. So we do that. And then we would say, oh, let's draw the eyes. So the eyes might have by default some size, I don't know, like a radius of 10. If we have the eye radius, you see, on just so all of this would be choices that we make ourselves in the smiling face. But then the size and for what the client of smiling face wants to do is would be 10 times 1.5, so 15. So we would draw, then of course the location of the eyes and so on would have to be figured out, but we draw eyes with a size of 15 here, and here, and so on. So this is really the only information that we need. Well, on top of that, we need another piece of information, which is give us a graphics window. You see, the smiling face is not going to create its own graphics window. Why is that? Because if it did, then the client could not give their own graphics window and say, oh, I would like you to draw something in that graphics window that is a smiling face. Because if the smiling face creates its own window, then there would be only one smiling face in that window. I mean, unless the smiling face creates plenty of them. But in general, you would like the client to have its own graphics window, and then it can turn to the smiling face, say, oh, draw a smiling face here at that location. And then it can turn again to the smiling face class and say, oh, draw another one at that other location, but in the same graphics window. So this is telling us that in terms of also an additional instance field that we're going to have here, so this is going to be the graphics window to display the drawing here. And this is going to be given by the client. So we would have here, you see, a private G window, let's say window. And then this is telling us that the constructor of smiling face then is going to take values that will tell us what X and Y scale on window are going to be. So here, of course, I need to import that again. So let's do it. So this is what you're going to see. So the code is already available on the class website here. Let me go there. So if you were to open smiling face here, you see that we have here the code for the constructor. So it would look like this. So what is going on here, and I'm just going to stop on that for today, but again, this is going to be explained in the video that is posted. This is just a design of the constructor. So we here, what we get here, we're saying whoever is asking us to create a spanning phase will need to give us a value of X, a value of Y, a value of a scale, and a graphics window. So they're going to tell us, here is a graphics window. I would like you to draw a spanning phase at location XY in the graphics window with that scale. So what do? Well, we receive that information as parameters here, X, Y, scale, window. We want to write that information in the instance field, which is here. So here is a little problem that we run into. Let me collapse this so that we can see everything. In the constructor here, we have variables that have the same name. So what do I mean by that? Inside of the constructor, we have access to the instance field. Remember, an instance field is available from here to the end of the class. So X instance field is available here. But we have also another variable here, which is the parameter X here. And that one is a local variable. Notice that Eclipse doesn't use the same color for this. So that X here is in some brown font. That one is in blue. So blue means, in the context of Eclipse, a variable that is available throughout the entire class. Here we have a variable that is only available inside of the constructor. So why do we give them the same name? Well, it's because, logically speaking, they're related. This is going to be the value of X that is given to us by the client of spanning phase. So whoever is saying new spanning phase. And we would like that value to go in the instance field here. This way, then that value of X is going to be available throughout the entire spanning phase class. But now, how do you copy that value of X in this one here? So an idea would be, so this is going to be the solution. I'm going to explain it. But an idea would be to do this. But if I do this, actually, it's a little bit silly. And this is why I get a warning here of Eclipse saying that what is done here doesn't do anything, because I'm taking this value of X and writing it back in that variable X. But what I want to take this value of X and write it in this one. The reason why I cannot just write X to access this one, it's because this variable X here hides that one. So what is that one? That one is an instance field inside of the object of type spanning phase that we are constructing in the constructor here. So I need to say access the variable X instance field inside of the object. So whenever we want to access something inside of an object, we can use name of the object dot and then the something that we are looking for. But what is the name of the object when you're inside of the constructor here or inside of any method of a class? Well, there is a keyword given by the Java language. It's also used in C or C++. It is a keyword this here. So this means the object that we are currently constructing. So when we say this.y here now, we're saying access the instance field inside of the object. And so we get that variable here. So if I want that statement to make sense here, I would say this.x. And we could then, after that, draw the spanning phase by writing all of the code here, by creating ovals and so on. It's a good idea instead to do it by using a private method. So this is what is done here in this code, where we draw the spanning phase below, and it's all cut into plenty of different methods here. But let me stop here at this point here. Again, now to end, so your learning for this week, go to the videos that are posted here, and that video in week 2 is going to explain how to create the spanning phase class and how to use it in PhaseSim. Okay, so that was just the introduction for graphics today. So now what we're gonna end up with for today is just for me to give you directions for your group work for the exercises. And the exercise is not meant to be difficult, so I hope it's not gonna be something that takes you a long time, but it will allow you to work in groups. So where is this? If you go on the calendar here, you're gonna find here in class exercises number 1. And I say in class, but after a while, it will be done outside of class. This is just to get started for the beginning here. So if you click on this, you're gonna see a set of questions to answer. So what I'm asking you to do is to write your answers on paper, work on it as a group, And once you're done with your solution, and it might be quite fast to do it, then go to Canvas and turn it in. And you're going to turn it in as a group. So where do you find the turn in? It is this here, written exercises. And so you're going to turn in this as a group. So you're going to have, if I go to student view here, you see you're going to have a box here that allows you to, well, a button here that allows you to upload a file. So upload something as a PDF. And you have some time to do it because you have 2 days to do it. And it's not meant, again, to be something that is a huge amount of work. So what is your written assignment? It is this. So the first question here has to do with what we said about state and behavior. So for that question here, it's asking, for instance, if you think of, well, it's a retired now rocket of NASA, but when the space shuttle was flying, of course, it had some characteristics. So for instance, the speed of the shuttle. So if you think of it as an object, would it be something that would be part of the state, or would it be a behavior? Then for B, when you think of so the payload of what the shuttle could carry, was that again part of the state, or was it a behavior? Or docking the shuttle, would that be a behavior of the shuttle or part of the state? So you need to just here for each one of these say it is a state or it is a behavior. For this, I'm asking you to, for each one of these, to give me the name of a class that would, when you instantiate it, you would get an object that would be one of these. And for the last one here, it's to draw a class diagram. So as was explained in one of the videos, you have it here actually. If you go to, there's this video here that explains class and object diagrams. So I'm asking you here to draw an object a class diagram to describe that class. So that you can get used to your group here. Well, I know we don't have a lot of time, but let me create breakout rooms, and I'm going to assign so each group to their breakout room. It would be best actually here if when you give me your name on Zoom now, if you could put your group number after your name, it's going to help me tremendously to go to create the breakout rooms. So you can find your group number by going to groups here, and you're going to find so you won't see all of this. This is the instructor view, but you're going to be able to see your the group you belong to. So then when I create a breakout room, I'm going to be able to assign you to that. So let me do this now. So I'm going to create 9 breakout rooms. So for instance, breakout room 7. So I'm going to assign Ethan, because you're in 7. Michael, I think you were 7. But you would have to change, don't tell me in the chat, I mean, you can. But if you change your screen name in Zoom, then I can see it directly, and it makes my life easier. Because if not, I have to go back and forth, and it's going to take forever. I don't know if I... So for instance, Nolan, I can put you in room 4. Fuc, I can put you in group 5. Donald, group 2. Eugen, you say you're group 1. Bo, group 7. Group 7 here. Abel, group 2. Anthony, group 3. Then, okay, so here I don't have the group of other people. So again, if you tell me in the chat, I mean, it's okay, but the chat scrolls up and down, so it would be better if you had your name, your screen name with a group number. So. Okay, so you're 4. Moses, you're 5. Koshal, you're 4. Anas, you're 8. Kolas, you're 8. So then Anthony, Ding, Hayati, Yuhi, I don't see your group numbers here. Eugen, you said you're group 3, but your screen name doesn't say Eugen. Is it Z? How do you change your screen name? Yeah, that's a good question. You might be able to click somewhere. Let me stop the share. And maybe when you... Let me see if I can find how you change your group. Let me see. So you're able to... Oh, yeah. So you go to participants, and then you go to more, and you can say rename. That's what it is. So you have to open participants, and then you click, you go to your name, and it says more, and then you can say rename. But let me continue here. So, okay, so I'm gonna... It might not, we might not have time to do it all, but you can also contact your group outside of class. Yeah. So, okay, so Eugen, I think you come as Z for your screen name, so you're gonna be in group 1. Youssef, you know your group? Oh, let me see here. So, King, I think you're in group 6.